Okay, hopefully homework went all right and you went over questions with Mrs. Squires first. I do have all the problems kind of worked out in a key. So after a few days and after I make sure I have everybody's assignment on e-backpack, I may send you the full-blown key just to make sure. But hopefully we did all right. Now today we're going to keep going on I can solve quadratic equations. We're going to move on to another method. Just to recap, yesterday you did solving algebraically. That's when there's no bx term. And then we also did graphing. So today we're going to move on to perhaps, I would say, the most important one, which is factoring. Factoring is not just used for quadratics, it is used all the time in every kind of math you can think of. We use it non-stop in calculus when we're doing something called derivatives and limits, integrals. We're going to factor over and over and over again. So it's very important we have good, solid foundation for factoring, because that is one of the biggest topics in all of math that kind of permeates all subjects. Here we go. Now I call this the ABC method. You've learned how to factor probably many different ways. I'm just going to show you one other way. Now from what I hear is many of you learned a algorithmic step process. You may have forgotten over the years. Many of you use the good old guess and check method, and that's fine to a certain point. Okay, because what if I give you some bigger numbers and they don't quite work? I'm going to do something called the ABC method. If we have a quadratic equal to 0, you have to make sure it's equal to 0. Okay. What you're going to do is you're going to multiply AC, and you're going to list the numbers that multiply to BAC. Okay, so let's say this number comes out to 12. You're going to list all the numbers that multiply to be 12. Then, you're going to look at your B. Those two numbers have to add to be B. So you're going to make a list of numbers here that multiply to be 12. Then you're going to pick the one pair that also add to be B. There's only ever going to be one solution there that will multiply to be AC, add to be B. This is why we call it the ABC method, because we're using all three of them, A, B, C. So let me just jump in. The first couple might be a little weird to you, so just stick with me. Okay, before we jump into the straight up good old-fashioned ABC method, let's refresh what a GCF is. I'm not here, but hopefully somebody can answer me what a GCF stands for. And that is greatest common factor. Is what do they have in common? So looking at these two, what do they have in common? That's what I'm going to pull out. I'm going to pull out that GCF. So they both can be divisible by 2, and they both are divisible by x. So I'm going to pull out that 2x. Now when I divide by 2x here, what am I left with? Well, I'm left with 16 divided by 2 is 8. Take out an x, you're left with 1 left. Now you have to see what's left here. Now a lot of people say, oh, nothing. It's gone. You took out 2x. There's always something left. And think about what you're doing. When you're taking out that GCF, you are dividing. So 2x divided by 2x is 1. Then we're going to solve this. And you solve this if you have two things that multiply to be 0. One of them, if not both, has to be 0. Because 0 times anything, or anything times 0 is 0. And that's called the zero product property if you've forgotten. So what I'm going to do is set both terms equal to 0 and solve them. Divide by 2, I get x equals 0. There's one answer. Subtract 1. Divide by 8. There's my other answer. There we go. Let's try another one. We're going to solve this by taking out a GCF. So look at your two terms. What are both divisible by? Well, 6 will go into both. X will go into both. So I could pull out a 6x, or I could pull out a negative 6x. It does not matter. I will tend to pull out a negative 6x because I like that A to be positive. Okay? But I know know a lot of you won't see this, so I'm just going to go ahead and pull out 6x. Divide by 6x, I'm left with 5. Once again, 30 divided by 6 gives you 5. You took out the x. Now you saw minus. What did you take out? Well, you took out 6. You took out an x. So you're left with 1x. Okay, now that you have two factors that multiply to be 0, set each factor equal to 0 and solve. So I will get x equals 0 as one answer. Subtract 5. Divide by negative 1. I get 5 as another answer. I'm not doing a full-blown ABC method yet. I'm just pulling out that GCF. That's really helpful when you only have two terms. It's kind of the quickest way to factor there. Okay, let me show you what a lot of people do that is wrong. I have a lot of people say, oh, divide both sides by x cubed. It'll reduce to this. Oops, sorry. It'll reduce. That was double wrong right there. Oh, so x equals 2. Done. That's so incorrect. Okay, you cannot divide by a variable. The reason for that is, what if that value is 0? You cannot divide by 0. So I need to take everything over to one side. I'm going to take this over. I like my highest power to have a positive coefficient. It does not matter, but I think it makes it a little easier. Now let's pull out a GCF. Well, they're both divisible by 3, and they each have x cubes. So what's left? Well, you took the 3. There's an x left. 6 divided by 3 is 2. You took all the x cubes. So now set each term equal to 0. By the way, after we do a few of these, you do not have to show this work. Okay? A lot of people can look at that and say, oh, boom, boom, answer, answer. But I'm just going to show you. A lot of people get confused here with the cube. Take the cube root of both sides, you still get 0. You still get 0. Add 2. Here's our answers. And now we see why you couldn't simply divide both sides by x cubed, because you cannot divide by 0. X could be 0 in this problem. The big no-no, world explodes, can't divide by 0. Once again, without you in here, it's kind of hard for me to determine if I'm going too fast. Please pause the video or ask Mrs. Squires to pause it or explain in more detail. Okay. But go ahead and now pause the video for the U try, factor out GCF. When everyone seems to be done, go ahead and push play again. Okay, I can pull out a 5 and an x squared. So when I do that, 35 divided by 5 is 7. I took both the x's. 15 divided by 5 is 3. I took 2 of the x's, so I still have 1 left. Now set each term equal to 0. Divide by 5. Plus or minus square root, you still get 0. Subtract 7. Divide, I get 7/3. There you go. No decimals. No decimals, remember. We want exact answers, either square roots or fractions. So that's our GCF. Now let's jump into our ABC method. Okay, in order to factor with the ABC method, everything needs to be on one side. You have to be equal to 0. So let's go ahead and set this equal to 0. Now, it doesn't really matter, but your life will be a whole lot easier if you leave that A, in this case A is 1, positive. Keep that A coefficient positive. So instead of taking and subtracting x squared, I'm going to move all of this over. So I'll get x squared plus 13x plus 42. When I take all of this junk to the other side, add opposite. But keep that A coefficient positive. Now, I know many of you will do guess and check, and that's fine on a couple things. It's fine as long as you get the right answer. Now, if you're doing guess and check and you're repeatedly messing up, then you're going to have to show work. But a lot of people do not like the guess and check method because, well, it's kind of shaky. You either get it or you don't. It takes some time. The ABC method will work every single time. So what I'm going to do is A times C, which is 1 times 42. Well, what numbers multiply to be 42? 1 and 42, 2 and 21. C3 goes into it. You do have a calculator, by the way, because some of these numbers may get big. I'm not sure. Go ahead, 1, 14. 4 doesn't go into it. 5 doesn't. 6 and 7. And by the way, once you get back here, see how 6, the next number would be 7. You've listed all the pairs. B is 13. So now look at your pairs that you listed. Which ones add to be 13? These two, right here. These two add to be 13. So what I'm going to do is I'm going to replace this middle term with 6x and 7x. So I have x squared plus 6x plus 7x plus 42. All I did was replace this with 6x plus 7x, which equals 13x, right? That's why they have to add to be that number. Okay. Now, put a line down the middle to kind of separate it. It's two different problems. What can you pull out of the front? What's a GCF? Well, I can pull out an x. I'm left with x plus 6. Over here, what can you pull out? Well, I have a plus. Don't forget that plus is still there. I can factor out a 7. I'll get x plus 6. Now, they better be the same thing. So notice inside my parentheses, I have the same numbers. X plus 6, x plus 6. That better happen every single time or you messed up. Because now what I'm going to do is I'm going to factor out, here's my two terms, x plus 6. What's left? Well, I took this, so x, took that, so 7. It's always going to factor to be what's in the parentheses and then the leftovers. Now, I know what some of you are thinking. Oh, that's a lot of work. I could have gotten that by guess and check. And yeah, it's a little one. If you like guess and check, go ahead and use that. Like I said, just make sure you're right, because if you're not right, I'm not going to give you any partial credit because you don't have any work. Okay? But as these get bigger and more complicated, as the A coefficient is no longer 1, they get a little more trickier to do the guess and check. So this method is kind of nice. Let's try another one. First, get it equal to 0. So subtract 3 from both sides. Okay, let's do A times C. Well, that's 2 times negative 3 is negative 6. So let's list the things that could multiply to be negative 6. But be careful. Negative 6. So I could have negative 1 and 6, negative 2 and 3, or 1 and negative 6, 2 and negative 3. Right? One of the numbers has to be negative if you multiply by a negative number. So right here, I know 1 is 6, 2 and 3. I made one of them negative, and then on the other one I just switched it and made the other ones negative. Now your B is 5, positive 5. So look at your pairs. Which ones add to be positive 5? Right here. Negative 1 and 6. Okay. So I'm going to replace this middle term with negative 1x and 6x. So I have 2x squared minus 1x plus 6x minus 3. Oh, by the way, does it matter which number if I switch the order? The answer is no. Not at all. It does not matter. You're still going to get the same answer. Your work might look a little different than your partner, but you're still going to get the same answer. Line down the middle. GCF here is x. So I'm left with 2x minus 1. What can I pull out here? Well, I still have the plus. Don't forget it. They have a 3 in common. I'm left with 2x minus 1. Which is what better happen. These better be the same things in those parentheses. So now factor out that 2x minus 1. You're always going to be left with the leftovers, the x plus 3. Whoops, I don't think I solved the last one. We'll go back here in a second. Zoning out here. So focused on the factoring and forgot to solve it. Okay, so we've got our factored equals 0. But once again, set each term equal to 0. I'll get negative 3. Add 1. Divide 1/2. There we go. I know this is new, so it might be a bit overwhelming right now. You may not have seen the ABC method before, or you may have done something similar. I'm not sure. Once again, this is a method that works every time. Let me go back because we forgot to solve this one. I had it factored. We forgot that it equaled 0. So set each one equal to 0. Once again, you do not have to show this. You should just be able to kind of look and say, oh, negative 6 and negative 7. There we go. Forgot to solve it. Whoops. Let's keep going. Let's keep trying a few because this is new. Once again, factoring is so important. So I have 3x squared plus 7x, add 4. AC is 3 times 4 is 12. So things that multiply by 12 are 1 and 12, 2 and 6, 3 and 4. B is 7. So which ones add to be 7? Right here, 3 and 4. So let's replace that middle term with 3x and 4x. So I have 3x squared plus 3x plus 4x plus 4. Line down the middle. Kind of separates into two problems. What can you pull out here? Well, they have a 3 and an x in common. So what's left here is x. Be careful, what's left after you pull this out? 1. Okay, it doesn't disappear. 3x divided by 3x is 1. Over here, don't forget your plus. You can factor out a 4x plus 1. Notice how they're the same. That better happen, because then what's left, we factor that out. Then the leftovers, 3x plus 4. That's still equal to 0, like we have from the beginning. So again, if I'm going too fast, please pause, or if you have questions, ask Mrs. Squires. She'll gladly help. Okay, so x plus 1 equals 0. 3x plus 4 equals 0. So x equals negative 1. Subtract 4. Divide by 3. Negative 4/3. This is nice for my algorithmic people. Some people like step 1, step 2, step 3, step do this, 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 this. And this is nice because the ABC method will work every time. That said, it will work every time a function is factorable. Now, not all quadratics can be factored. In fact, it's kind of rare that they can. So remember when I told you yesterday that when I give you a quiz, I'm going to say use each method twice. You have to know which ones to use which method on. So the first thing I would look for is which ones can you solve algebraically? In other words, which ones has no bx term. Then the second thing I would look for is which ones can factor. Because not all are going to factor. You may not find two numbers that multiply to be AC and add to be B. If you don't have two numbers, it doesn't factor. Oh, this one's good. This one's good because it's different. What's that degree? The degree is 3. This isn't a quadratic. And the ABC method is only for quadratics. But I can pull out a GCF first. See how they all have an x in common? Factor out an x. Now we're just going to work on factoring this. The x does not go away. We're going to keep carrying it along. When we're done, we're going to bring it back in. I'm just going to work on factoring that. So a times c, 1 times 40. So let's list the things that multiply by 40. 1 and 40. 2 and 20. 3 doesn't go into it, 4 and 10, 5 and 8, and that's it. Now, they have to add, oh, this is a good problem, to be negative 13. We have to think a little bit here. 5 and 8 do not add to be negative 13, they add to be 13. So if you multiply to be a positive 40, you could have two positive numbers, or you could have two negative numbers. Because negative 5 times negative 8 does multiply to be positive 40 and adds to be negative 13. Here's a hint. Look at this sign. If it's a plus, both of your numbers are going to be positive or negative. They're going to be the same sign. And they're going to be this. So if it's a plus, they're both going to be negative. If this was a plus, be plus, they're both positive. So this tells you they're the same, and here's what they are. Now if this was a minus, it tells you they're different. So I'm going to replace this middle term, negative 5x and 8x. So I have x squared minus 5x minus 8x plus 40, laying down the middle. So I can factor out an x minus 5. Now here's the thing, I could factor out an 8, but if I did that, let me just show you. It's incorrect in a couple of respects. But if I factor out an 8, this is what will be left, plus, not minus. Okay. You have to factor out that negative 8. Because that will give me x minus 5. Because 40 divided by negative 8 is negative 5. They have to match. Have to match. So now factor out your x minus 5, and then the leftovers, x minus 8. Now here's where, don't forget, this right here. It's still there. It's still a term. So when I go to solve this, set each term equals 0. X equals 0 from this one. X minus 5 equals 0. X minus 8 equals 0. So x equals 8. X equals 5. And x equals 0. This has 3 answers. But this does not contradict what we talked about yesterday, how a quadratic can have 0, 1, or 2. This did not start as a quadratic. This was a cubic. And cubics can have up to 3 answers. Alright, let's keep going. So here's another one that's a cubic. So let's factor out a GCF. So not only can I take an x out, it looks like I can also take a 2. They're all even. So let's factor out a 2x. Try to make it as small as possible. So I'm left with 2x squared plus 5x minus 18. Now, we're not going to forget that. We're going to put it back in when we're done. Let's just focus on factoring this. So AC is 2 times negative 18, negative 36. B is 5. Now, once again, it multiplies to be a negative number. They're different signs, so I could have 1 and 36. Just going to list my pairs first. 2, and let's see, 1, 18, 3 and 12, 4 and 9, 6 and 6. So, a couple things could happen. I'm going to write all the same pairs down again. Just to show you all the possible options. I'm going to write the exact same pairs down. So I could have the first number negative or the second number negative. But either way, which ones add to be positive 5? It's like right here. Negative 4 and 9. That would be positive 5. So I'm going to replace that positive 5 with my 2 numbers. So 2x squared minus 4x plus 9x minus 18. Line down the middle. GCF is 2x, which leaves me with x minus 2, which means that's what I need to get over here. So what did I have to pull out? I had to pull out a 9. So factor out an x minus 2, left with 2x plus 9. Those are my leftovers right there. But don't forget your 2x that we start with. That's still out in front. I still have it, a GCF in front. So when I set this equal to 0, set each term equal to 0. Set 2x equals 0, x minus 2 equals 0, 2x plus 9 equals 0. So that would give me x is 0, x is 2, if you had extra time or test and quiz, this is an equation. Plug them in. You do have calculators on this quiz. Okay, so you can plug this in fairly quickly on a calculator. Once again, it's really hard when you're not in the room for me to judge if you're understanding or if I'm going too fast. So please ask Mrs. Squires for help or to pause the video if you have questions. So right now, you try, get it over, make sure it's equal to 0. Then go ahead and start factoring. When everyone seems to be done, go ahead and push play again. Right now, pause it. Okay, let's go over it. 4x squared minus 27x minus 7 equals 0. A times C is negative 28. B is negative 27. By the way, you don't need to list all the pairs. It's just a kind of if you're stuck. I'm guessing it's 1 and 28. Now the question is, which one is it? One of them has to be negative in order to multiply to be a negative number. To add to be negative 27, so right here. So you write that middle term with your two pairs. So I have 4x squared plus 1x minus 28x minus 7. Pull out an x. I'm left with 4x plus 1. Over here, you need to get 4x plus 1. So you're going to factor out a minus 7. So that will give me positive 4x, positive 1. Factor out 4x plus 1, x minus 7, that's equal to 0. Now set each term equal to 0. X is 7. Subtract 1, divide, negative 1/4. Here we go. Hopefully we did all right. If not, make sure you're asking questions. Try your best. Now one last thing we need to talk about, and that is perfect squares. Perfect squares are very quick to factor if you recognize them. A perfect square is when you have a squared minus b squared. It's got to be a minus. If this is a plus, it does not factor. Okay? So if I have a perfect square, so for instance, x squared, that's a perfect square. Other perfect squares, let's say it's 100. 100 is the perfect square. That is 10 squared. Okay? So if you have a perfect square minus another perfect square, it will factor out a minus b, a plus b. I think we kind of remember because somebody said this the other day. So let's use this example. Let's say x squared minus 100. What's being squared here? X's. So it's going to be in front. And what's being squared here? 10. Make sure one's minus, one's plus. And then we can quickly solve it. That is every time you have a perfect square minus perfect square. Let's do a couple of those. So hopefully you recognize x squared minus 36. Now I know we could solve this algebraically. I want practice factoring, so we're going to use factoring on this. So what's being squared here? X. What's being squared here? That is 6. One is minus, one is plus. It does not matter which one. Set it equal to 0. Hopefully you can now see the answers. That will be 6. That will be negative 6. If not, go off to the side and set them equal to 0. We should start to get to that point where we can kind of look at them and just know the answer. Okay. Perfect square, perfect square. So what's being squared here? 2x. This is 2 squared, that's x squared. Put that in both places. What's being squared here? 5. One's plus, one's minus. Set them equal to 0. Hopefully you can see it. That will give me negative 5 halves. This is going to be positive 5 halves. Once again, if you need to go off to the side and actually set each one equal to 0 like this, please feel free to do so. You just need to be getting to that point where we can just look at them, but if you need to do that, please do it. I'd rather you do that than get it wrong. See, these are short and sweet. Now, this is not a perfect square minus perfect square yet. Let's take out a GCF. I can take out a 5 and an x. I'm left with 1, don't forget that's still there, minus, divided by 5 would be 9x squared. Well, that's a perfect square in perfect squares. 5x is still there. What's being squared here? 1. What's being squared here? 3x. One's a plus, one's a minus. Does not matter which one. Okay, so let's set these equal to 0. Here we'll get 0. Here you might have to go upside and do that one if you can't see it. Subtract 1. X is 1/3. Likewise, that will give me, oops, I dropped my negative. Positive 1/3. There we go. So recognize those perfect squares. Makes it nice and neat. So quick, you try, pause the video, and hit play when everyone seems to be ready. Okay, perfect squares, we have 5x, that's 4. One's plus, one's minus, doesn't matter which one. Equal to 0. You can set each one equal to 0, but you will end up getting negative 4/5 and positive 4/5. And yes, you could write that as plus or minus 4/5, however you like. Okay, homework tonight is another handout. I got rid of my day 2. So in your OneNote, 3.3 day 2 homework, you got a clue. This is not a scavenger hunt, but on a separate piece of paper or below, do not squeeze in work right here. Don't do it. Everyone's listening to me a million times. Do not squeeze it in here. We're going to solve each one, and then when you get an answer, cross it off. Okay? Whoever's left over is who killed Mr. Factor. Please write that in here, the who, what, and where. So you've got a bunch of factoring problems. Go ahead and the rest of the period, go ahead and work on those. Finish tonight.